Welcome everybody to today's Space Analog Stories. Today I am speaking with Anushree Srivastava. Anushree is a doctoral fellow in astrobiology at the Open University in the UK. Prior to her astrobiology PhD, Anushree also studied anthropology and biotechnology. She has been featured in the 1 Million Women in STEM campaign. As part of her research, Anushree has worked with NASA and been crew member for 3 analog missions at MDRS in Utah and FMARS in the Arctic. Welcome, Anushree.
Hi, Jess. Thanks for having me.
Oh, it's an absolute pleasure. So would you mind just starting with giving us a little bit of a background of first how your interest for space started, and then how this led to your current research and your involvement with space analogs?
I think my interest started when the Columbia disaster happened. You know, the first Indian astronaut, Kalpana Chawla, she became part of this STS mission. So if people remember, that disaster happened in 2001 or 2. So I think that was an event for me. I mean, that gave me some sort of, a kind of awakening that, wow, this is something like people can go in space and do some, cool stuff. And in the kind of buzz that it kind of created, like when the disaster happened and we had an Indian origin crewmate there. So it was like I said, it was an awakening for me. And I think that was the first ever kind of burst of, this space adventure and exploration. And it started for me. So yeah, I would say Columbia disaster, that was the first incident. And after that, it has started like it did not even a single moment, I would say, but it's a kind of combination of different, incidences that happened. I remember that back then I was preparing for civil services examination. So I had no idea what I'm going to do, like about space and astrobiology, and I just had no idea about it. But while preparing for my examination, I came across this word, space biology. And that was something like, what is this? I mean, how can you study biology in space? I couldn't believe it. So I would say, so that was something that fascinated me a lot. And I thought, I think I am made for exploration, not for, being in the office and being a civil servant.
Yeah.
So that's how it started for me. And then I started searching for more astrobiology programs. And since I had arts degrees, not the science degrees, I was doing anthropology, which is Master of Arts degree. And it was so hard for me to, just switch the so drastically different science disciplines.
Yeah.
So it took me time and a lot of hard work to prepare myself to get a science degree. And fortunately, I got a Master of Science degree offer from University of Essex in Colchester. So I did a biotechnology degree there. And while I was studying biotechnology, my 3 months master's project was related with, search for fossilized DNA signatures within 6 million years old sodium chloride crystals. So I studied that for 3 months, and that was again a very adventurous and exciting area of research for me. And that's where, that's how it all started for me. And then I just kept exploring more PhD programs dedicated to astrobiology and microbiology, because my training was in microbiology during my master's. So yeah, that's how it all started, and my interest for space analog missions. So right after finishing my master's degree, I got this opportunity, actually call. It was an invited call that, would you like to be part of Mars 160 mission? Because I was part of Mars Society as a volunteer since 2013.
Oh, right.
So they were kind of observing my work, and the director of MDRS, Dr. Shannon Rupert, she wrote to me, and I also proposed to be part of a short-term MDRS missions, like 15 days rotation. But my application went to them at the right time. So, I mean, you can say that I was fortunate. So she saw my application, and she was also, planning the same research area, like astrobiology of Martian salt.
Yeah.
And I was doing the same thing as part of my master's research. So it all came together, and I said, yes, why not? I mean, this is a great opportunity for me to be part of the Mars 160 mission, which was a first ever long-term simulation mission that Mars Society was conducting. So that's how, I mean, I got into this analog mission.
That sounds, that's amazing.
Started as a volunteer. It started as a volunteer and then became part of this very ambitious mission.
Yeah, that's amazing. I love that story. Can you just explain a little bit more about the sort of crystal salt and the search for like the microbes or
Okay. Yeah, so Mars has a lot of salts. You can say that Mars is a salty planet.
Yes.
So it has all kinds of salt. It has chlorides, it has sulfates, it has carbonates. So how this hypothesis started, because on Earth, we see that ancient salts, ancient sodium chloride crystals, somehow, encapsulate tiny, microorganisms inside some fluids, because, when seawater evaporates, some fluids get trapped within the crystals. And that fluid kind of provides a habitable microenvironment within a salt crystal. Right. So those microbes get trapped and they can survive over so long period of time. So that's how it all started. Like, if on Earth it can happen, why not on Mars, when Mars has a lot of salt?
Yeah.
One can imagine, like, it's a very straightforward path, but it's not so straightforward because Earth and Mars conditions are so different. Yes. Mars has been encountering a high doses of radiation for about 3 billion years. So it's not so straightforward, but the hypothesis is that, it can be imaginable, because Earth salts can host life. So why not Mars?
So do you believe that? Yes. So do you believe that Mars itself might have this sort of life forms?
I really believe that, because not in the present condition. Like, present condition is so harsh on the surface, but subsurface, definitely there is a possibility. But since we know that ancient Mars had lots of water on its surface,
yeah,
and water got evaporated, and now we can see some, geomorphic signatures of the presence of water. So yes, I mean, if Mars was habitable in the past like Earth, it may have, it is a possibility that it had life also. And now what we can find today is just the signatures. It's just the remnants, the fossilized signatures of if any life present on Mars in the past.
And aside from the Earth, obviously, and Mars, where do you think life is most likely to exist in our solar system?
I would say icy moons. Have you heard about icy moons? Like the moons of Jupiter, which is called Europa,
yeah,
and the moon of Saturn, which is called Enceladus. So both the moons are giving off water vapor plumes. It's coming out of the surface. It's like a fountain. So it means that some sort of hydrothermal activities are happening inside. That's just beneath the surface. I don't remember the depth of the ice sheet on the surface, but because the water plumes are coming out, it means some ocean exists beneath the surface. So I think that sounds very hopeful for me, because we know that the prime requirement for life is water, liquid water.
Yeah.
So if those planets, if those moons have liquid water beneath the surface, then we can definitely imagine that there might be some micro life could be existing there as well.
Yeah. And so,
yeah. And very recent study on if you heard about phosphine molecule in the clouds of Venus. It's very, very debatable, but it's a good possibility. Like, I think science community is looking forward to, you know, more follow-up experiments, so that something can be said for sure. Like on Earth, phosphine is only created by life. We don't know any other way, you know, abiotic way, so that phosphine can be created. So
Yeah, that was extremely exciting.
exciting, but very controversial.
Venus was not considered before as a possibility for life. I don't think anyone had thought of
Yeah.
Venus as that.
Yeah.
So going back to sort of general space exploration, how do you feel that, what do you think are some of the biggest challenges, and how do you think that the space analogs help to address those challenges?
I see a couple of challenges. I mean, the biggest challenge is building a sustained system, like, you know, a sustainable system, because back and forth mission are going to be very, very resource consuming. You know, if any Mars colony would have to be a kind of self-sufficient. So I think that's the biggest challenge, and how space analogs are helping that, because I remember in our mission at MDRS, we had a sort of, we call it smart pots, that would simulate the sunlight, and we would grow lettuce and dill and tomatoes. So this kind of food we would grow, and we would see like how this pot is helping to you know, to have our own food, and it was really successful. So one way I would say that's how our mission kind of tested how we can grow our own food. And I remember past MDRS mission, some members also kind of extracting water from hydrated sulfate salts. So that was also cool experiment that they did. So I think that's how the missions are helping. And I would also say that one of the challenges is isolation.
Yes.
You know, if you go to from Earth to Mars, it's going to take about 9 months of travel and then living there. So you know, it's mentally, emotionally very challenging, very demanding. That's something I also learned when I was part of, you know, 5 months simulation mission.
So was it 5 months in MDRS, and how long was it in FMARS?
No, it's a 5 months in totality. So there were 3 months at MDRS and 2 months in the Arctic.
Okay, and how did the two compare? The experience between the Utah MDRS one and FMARS in the Arctic?
You don't compare, because they're two different environments. It'll be comparing, you know, apples and oranges. So you don't compare. It's just that each of the site has its own flavor. Has its own challenges. I would say living at MDRS is a bit easier than FMARS, because it's the Arctic, is the largest inhabited island, and you know, we were just 6 people on an entire island. As opposed to MDRS, you have like a civilization just a few kilometers away.
So did you go straight from MDRS straight to FMARS?
No, we had a couple of months gap.
Okay.
Because we needed to prepare, we needed to do a lot of meetings and a lot of logistics stuff. We needed to sort out everything.
But
so it was a gap of a couple of months.
Yeah, 5 months is a really long time. I'm not at all surprised that was quite difficult.
Yeah. So initially it was a 1-year mission in the Arctic, but that couldn't happen. So we had to separate it into two chapters, like 3 months in Utah and 2 months in the Arctic.
Do you think you'd ever go back and do another analog mission?
If given opportunity, definitely, especially in the Arctic. I would love to go back again.
It sounds amazing.
It's not easy. I would still say it's not easy. It was very, very challenging. In every way. Yeah.
Do you have any interesting or funny stories you can share about some of your time on the analog missions?
Yeah, I do have. So I would say in the Arctic, when there were twice, like it's like in some places that's like kind of muddy lands, like it's like a swamp.
Yeah.
So I was wearing a spacesuit which would weigh about 15 kilograms. So it happened to me twice that I literally got bogged down in the swamp. And wearing that much weight on my body, it felt like I'm going down and down and down.
Oh no.
I was so scared. I was so scared, like I'm gone. Nobody can save me now.
Yeah, that
And
sounds
not
scary.
just one, can you imagine? Not just one, it happened to me twice.
Oh
And
my
who are my crewmates? They used to drag me out. Some are just taking off my helmet and just trying to take me out from that. I would say they're funny, but it was scary, but again, funny also.
It's something you can laugh at after the event has happened.
Yes, yes, and we still remember that incident, and we laugh.
Really, if you want,
I laugh at myself.
you have to laugh at yourself, absolutely.
Yeah.
Did the others happen to all of the crew as well, or were you just
No, just
the
me.
lucky one?
Just me. I was the lucky or unlucky because I don't know what. At least I can tell the story.
Oh, that is
I
funny.
felt that trauma of going inside the song.
So, if imagine you got to actually travel to Mars for real, would you take that opportunity? Would you want to go to Mars?
Yeah, I would like to go, but not one way. Not one
A
way
return
mission.
trip.
I would like to come back.
Yeah, I'm with you on that one.
Yeah, I would like to come back with some really precious samples. I would go collect samples and come back as an astrobiologist.
But the journey itself, I mean, that's a very long journey.
It's very long. It's 9 months. That's why it's daunting, actually.
Yeah,
just 9 months. And like I said, you have to be prepared mentally. And isolation missions are really helpful in that way because they give you that sort of environment where we are detached from all kinds of, outside world.
Yeah.
You cannot talk to your parents. You cannot, be in touch with your friends. So it's just the crew is your family. Is everything.
Aside from obviously you'd miss your friends and family at home, aside from that, what do you think you would miss most about a long journey to Mars?
Obviously my family.
Aside from
my parents and food. I would miss the food. Yeah, I miss the food, but I would miss the earth also, earth itself, because it's no place like earth.
Yes.
So I would miss that too. Yeah.
If you could take one thing with you, putting aside like family photos and things like that, what one item do you think you'd want to take with you on this journey?
Good question. Yeah, I would say a jar of pickle.
Oh, really?
Lime and mango pickle.
Oh, wow.
That's gonna save my life. That's gonna save my life.
Like a
because
jar.
if you have pickle, you can eat any food with that, and you have all the spices and sour taste.
So what's funny about what you just mentioned is during lockdown here in the UK, my dad said to me, as long as we have a jar, pickle basically, and enough atta, so flour to make roti, like flatbread, we can last all year. I'll be perfectly happy.
You're good.
We're good. So as long as we have those supplies.
I agree. I totally agree. Even if you have rice and pickle, that's enough.
Yes. So getting back to your research, what is it you're currently working on?
So I'm working like salt. I mentioned about salt. So my research it's sort of building on my master's work. So at that time I was focusing on sodium chloride, but this time I'm focusing on sulfate salts.
Okay.
So exactly the same. I'm trying to. So my work is completely experimental controlled laboratory work. I'm not, doing any kind of field work or dealing with any natural samples. I'm making my own samples.
Yeah.
So I'm making a simulated brine that we would expect on Mars, and the Mars in about 4 billion years ago. Like we said that hopefully there was some water on the surface of Mars at that time. So I'm kind of simulating that brine, which is salty water. Mm-hmm. And I'm putting microbes in that. I'm evaporating the brine and testing the growth of those microbes in the brine and how their signatures can be preserved and detected. So that's the basic idea of my PhD project.
That sounds very interesting. And I don't know if you've thought this far in the future, but what do you think your future plans in space will be after you've sort of completed your PhD research?
I don't know. I never planned. I never thought about 10 years back. I never thought that today I'm doing what I'm doing. So things. The only thing I would say that I never stopped dreaming. my ambitions are high, my expectations are high from myself. So, and I'm ready to work hard.
Yeah.
So now whatever life gives to me, I would welcome it, and I would just go on the journey.
That's a
So step
wonderful
by
answer.
step, I don't, I don't plan so hard.
Yeah.
It's just I keep doing my work at hand in the present, and look forward to the future. That's all I can say.
Brilliant attitude. I love that. So is there anything else that you would like to share with our audience today? And if anyone wants to get in touch or follow your work, how can they do that?
Well, if you want to get in touch, then get in touch. I'm always ready to answer you. I mean, I'm on Twitter, I'm on LinkedIn. So people just can,
Twitter, LinkedIn,
give
reach out to
me
you.
their questions, and I'm ready to answer. Yeah. So that's not a problem. I'm always there. In terms of any advice, the one thing I have always followed in my own journey is that I never considered a work insignificant or small. Every work was important for me, and I did everything with the same amount of dedication and passion. So that's something that I always suggest people, that don't think, no, this is too small. I mean, you don't know what, something can give it to you, like what you're going to end up with. You never know.
Yeah.
And that's exactly happened to me. When I was a volunteer of Mars Society, I was just a very small part of the big idea.
Yeah.
I mean, I was just assisting the on-site crew remotely. Uh, and I'm being very honest that I never knew that Shannon one day is going to contact me and ask me that, would you like to be a part of Mars 160 mission? I mean, that was something for me, because she saw something. She
Yeah.
saw the dedication, and she literally told me that I think that if a girl can do such a small thing with such a great dedication, she's the perfect person for this role. So,
Yeah.
I mean, that was a learning for me. And that's how I realized that, you have to do your work with the great dedication and passion, without even thinking what the result is going to be.
Yes.
So
You never know
just
what.
do the work for the sake of it.
Yeah.
Just do the work for the sake of it, and never think that this is too small or this is too big.
Yeah.
Yeah. So I mean, this is something that I have learned. So I'm just sharing my own experience.
No, I think that's a really excellent advice. I do. Anushree, thank you so much for joining us today for this conversation.
Thank you, Jess. I mean, it's my pleasure.
It's an absolute pleasure.
Nice talking to you.